Okay, I'll be starting with the unit number 4, that is structural testing, which is very, very important, which you have to know. Okay, uh, what do you mean by structural testing? As name itself suggests, you are going to consider the structure of the code rather than functionalities that you are going to implement. Okay, then structural testing, it is the type of testing which is basically carried out to test the program structure or the way you have written the code. Okay? And it is also known as white box testing or glass box testing. Both are one and the same. What do you mean by white box testing? White box testing basically deals with the structure of the code. You are more focused on the way you have written the code or the structure of the code rather than functionalities. Okay, you are not going to test the functionalities or the requirements checking. You are testing the structure of the code, the faults associated with the structure of the code. That's why I call structural testing as white box testing or glass box testing. Okay. In order to carry out or perform this white box testing or structural testing, you have to have a thorough knowledge about the code that you have written. That's why it is mostly carried out by the developers rather than testing team separately. Because testers, the one who test basically assign the work of testing, that team will be actually isolated from the development team. The team is going to be different in the real world scenario. But here, since white box testing deals with the structure of the code, you need to have the thorough knowledge about the code. Who will have the thorough knowledge? The one who has developed it. That's why this is basically carried out by the developers. Okay, and this is more the structural testing. It is more concerned with how system implements it rather than what it implements. Okay, I hope everybody is understanding this. This basically deals with how the system is going to implement the functionality rather than what it is implementing. Which are the functionalities it is implemented, we are not interested. How we are implementing it. Which all are the things that I am going to make use of within the code that is being tested. Okay, so I'm more concerned with the structure of the code rather than the functionalities. Okay, and it aims to cover or test all the nodes and the parts which are being present in the structure of the code. Okay? These things are basically covered in structural testing, which is also known as white box testing or glass box testing. Okay, then it is contrast to the functionality testing because using this particular technique, that is structural testing technique, okay, test cases are drafted, okay, based on the system requirements, are first analyzed, then more test cases are added to the list in order to increase or cover more nodes and edges in the structure of the code. Okay, the number of test cases are not fixed here. Okay, because see, what is the difference that we are finding with respect to functionality testing and structural testing is that with respect to functionality testing, you know which all are the functionalities that you are going to implement, and based on that, based on the requirements, you are going to have fixed set of test cases which are being drafted to test the specific functionalities of a particular software. But whereas structure of the code, will it be fixed always? You are going to add on always based on the requirements. Okay, so you will have certain set of test cases which are being designed earlier. Later on, okay, you are going to add more test cases in order to cover each and every statement of the code because the testing has to be very thorough. Okay, each and every line which are being written inside your program should be tested properly. Okay, that's why you are going to have more number of test cases which can be added further to increase the coverage or in order to increase, in order to have thorough testing. Okay, and this particular testing technique can be applied at various levels, such as in order to test a particular module or a particular component. I call it as a unit testing or component testing. And it can also be applied at integration testing whenever n number of components have been taken together. I call it as an integration testing. You integrate and try to test the functionality as a whole. Okay. Can also be applied at integration testing, and this can also be applied at functional testing level also. Okay, and structural testing is mostly automated. It is not carried out manually. There are certain tools which are available for carrying out structural testing. That is testing the structure of the code. Okay, before studying this structural testing, you need to have the knowledge about certain things like control flow graph. Okay, what do you mean by control flow graph? We are dealing with this term since from many classes we are using this particular terminology. What is that? Control flow graph is a graphical representation of the program which will tell you about the paths, okay, which are being traversed during the execution of the program. Okay. That basically tells you about how the control is being shifted from one node to another node via a certain path. Okay, and control flow graph, it is going to have a node and an edge, n number of nodes and n number of edges. Node is also referred as block. Okay, and you already know set of statements or sequence of statements will form a block, and a particular block is going to have one entry point and one exit point only. Okay, whenever particular statements which are being included within the block will form a block, okay, or a node is going to have one particular entry point and one exit point, and edge will always represent the flow of control, how the control is getting transferred between the nodes. That is represented by making use of a edge. Okay. Let me explain that with the help of a diagram. Okay. How many nodes are present? This is typically a CFG, that is control flow graph, where you have 5 nodes, that is maybe N1, N2, N3, N4 and N5. Okay, these are nodes or blocks, basic blocks of CFG. And you also have edges, that is E1, that is connecting N1 and N2, E2 connecting N2 and N3, E3 connecting N2 and N4, E5 connecting N4 and N5, and E4 connecting the nodes N3 and N5. Okay, and these nodes will represent blocks which are including sequence of statements of your code, whereas edges will represent the control flow, how the control is being transferred or shifted from one node to another node. Okay, this is simple example for control flow graph. After that, we have already looked into one term just few minutes back, that is adequacy criterion. Okay, it's a singular. Criterion means singular, criteria means plural. Okay, we are dealing with single adequacy criterion now. Okay, this particular term refers to the coverage provided by a test suite. There is a difference between test case, test script, and test suite. Okay, how much of the code is being covered by the test cases which are being included in the test suite? I call it as an adequacy criterion. How much it is possible for me to test via test cases a particular code. Okay, I express it in terms of percentage. Adequacy criteria is being expressed in terms of percentage always out of 100. Okay, so that is what I call it as adequacy criterion. Okay, after that I have the techniques for structural testing in order to test the structure of the code. One of them being statement coverage. Okay, first and foremost, the technique which is included within structural testing is statement coverage. As the name itself indicates, it is dealing with the statements which are written within the program. Okay, and what is the main objective with respect to this technique is to test all the statements which are present in the code. Okay, and ideally, I'm using the word ideally here. Practically, it is not possible. Ideally, the adequacy criterion should be equal to 1 or it should be 100% coverage. That means you have to test each and every statement of your code. Whenever you test all the statements which are present in the code, it will form 100% coverage or the adequacy criterion is going to be 1. Okay, then I can say that it is a good measure because you have written the test cases in such a way that you are covering all the statements of your code. Okay, but this technique is not suitable for testing the flow of control within your code. It will just simply test the statements whether they are being executed or not. That's it. Okay, but in order to test the flow of control, this is not good technique. For example, one node can be reached from multiple nodes within CFG. But my aim with respect to statement coverage is to check or to test the statements. Some conditions are not at all covered. Okay, I cannot traverse from all the nodes to reach a particular node. Why? Because here my objective is to test a statement, not all the parts in order to test the flow of control. Okay, that's why this is not a good technique in order to test the flow of control. Which technique? Statement coverage or statement testing. That is not a good technique. If you are just testing all the statements execution, whether they are being executed or not, you have to write the test case for testing each statement of your code. Okay, that is what I call it as a statement coverage. After that, okay, let me explain the statement coverage with the help of the CFG. Okay, here there are the statements present. These are nodes. Okay, don't get confused over here. These are nodes. Nodes in turn will have statements, sequence of statements. Okay, here all the statements can be covered using two paths. Okay, that is from E1 to E2 and E5. And one more path can be E1 to E3. Okay, this just by looking at the diagram, you'll get to know about it. But what about this? You have one more edge that is connecting the nodes N3 and N4. Okay, is it possible for me to write the test case wherein I can test for this particular flow of control, where the control is getting transmitted between N3 and N4? Okay, that is not possible. That is not covered using statement testing. Okay, whereas these parts or this particular statements which are present along these paths can be tested by traversing through the path E1 into E5 and E1 and E3. Okay, but that is not possible. This E4 is there, no, that is not possible. Okay, but okay, using the two statements from N3 to N4, it is not tested. Okay, it does not provide any branch coverage because N3 has got two exit points. N3 has got two exit points wherein I am just testing only one branch which is coming out of N3, that is E5 is being tested, whereas E4 is left untested. Okay, they have just taken one scenario, okay, wherein they are able to test only to the statements which are coming across this path and this path, whereas the statements which are coming across this particular path is not being tested. Okay, that is one limitation with respect to statement coverage. How can I measure the coverage, statement coverage? That is, there is a formula for that. Here it is a formula, that is total number of executed statements. This is represents number. Hash represents number. You can write number of executed statements has to be divided by total number of statements present in the code. That will give you the coverage statement coverage. Total number of executed statements divided by total number of statements present. That will give you the coverage. If you do into 100, you can express it in terms of percentage. In terms of percentage. Okay. We always express coverage in terms of percentage. Okay. After that, I have something called branch coverage, similar to statement coverage. Why we go for branch coverage? As you have seen in the previous example, certain things are not covered with the help of statement coverage. In order to overcome that limitation, we have to go for branch coverage. It is also known as decision coverage because branch is always associated with a decision. Whatever value is being evaluated based on the condition that you have written, you are going to traverse the branches. For each condition, there is going to be two branches, either true or false. Okay? And you are going to test the branches of a particular condition in this branch coverage. It is also called as decision coverage testing. Okay, what is the aim over here? In order to test the branches or edges at least once by making use of a test case. Okay, suppose you have two branches for a particular conditions there. You are testing each one of them at least once. In order to test at least once, you should have a test case, right? Which is being designed for each branch. Okay, so it provides a solution for the problem which was not covered in the previous statement. That is, E4 was not traversed, but with the help of branch coverage, I will test this particular branch as well as this particular branch also with the help of branch coverage. So that is possible with the help of branch coverage. Okay, then it is better as compared to statement testing, but it has also got certain limitations. Okay, what is that shortcoming? Okay, it will not provide a good coverage from different conditions that are leading from node 1 to node 2, as it covers that branch only once. Okay, here from node 1 to node 2, okay, you are going to have only one path over here. There is no conditional statement as well. Okay, so what they're telling is that, okay, it will not have a good coverage from different conditions, which will lead from node 1 to node 2. Suppose you have two nodes, it is not with respect to the previous example, okay, and if there are different conditions, okay, wherein you can reach from node 1 to node 2, it is possible for me to reach node 2 via node 1 only once. If I go for this branch coverage, if I write a test case and if I am doing branch coverage, it is possible for me to traverse from node 1 to node 2 only once. Okay, that is one of the shortcomings which is being associated with branch coverage. Okay, here the point you have to remember is that with the help of branch coverage, I am able to test the branches which are associated with a certain condition at least once by writing the test case. And it is better than the statement coverage. And what is the adequacy criterion? Okay, the adequacy criterion for this particular branch coverage is each branch. Branches usually it is represented by the edge in the CFG. It should be executed at least once. That is the condition. If I want to perform this branch coverage, then what is the condition? The condition is that the branch of a particular, the branches which are present in the program should be executed at least once. And how do I compute the coverage? That is as same as the previous one. Total number of executed branches divided by total number of branches. Okay, this is the formula for branch testing coverage in order to complete branch testing coverage. Okay. After that, let me take up one example over here. I have a node 1 and I have a node 2 and node 3. Okay. I have written one simple condition over here. Suppose if A is greater than 2 or B is less than 8, this particular condition will have two possibilities, either true or false. If you supply a value for A as 3 and the B value as 4, 3 is it greater than 2 and 4 is it less than 8? Definitely. Then it gets evaluated to true value and N2 gets executed. So I have a path or I can test the traversal from node 1 to node 2. Then it is sequential from node to node 3. I can have test case which is designed for testing the traversal from N2 to N3. Because 100% branch coverage is provided, because I can traverse, I can write the test case in order to test this true value also, false value also. Let me take up one test case where I am supplying the value for A as 1 and B as 9. Is 1 greater than 2? No, it is false. Is 9 less than 8? No, false. So I can traverse from N1 to N3 via E2. Okay. So in this case, 100% branch coverage can be provided via this traversal E1 to E3 actually, not E2 here, E1 to E3. Okay, they have done it E1 to E3. It is E1 to E3. Okay, edge even can be tested for multiple conditions. Okay, but under branch testing, the aim is to test the edge for one condition, not for multiple conditions associated to it. The different conditions can be A can be true and B can be false, or A can be false and B can be true. Okay, so you are going to test for only one condition and you can achieve it for branch. Okay, what is a branch coverage? For a particular branch, you are going to have a test case to test a particular branch. There are two branches. Okay, please remember there are two branches. One branch is associated for true value and another branch is associated for false value. Okay, this is about the branch coverage. Okay, one important point that you have to remember for branch testing is you are testing the edge for one condition only, not for multiple conditions associated to. Okay, that is A. The different conditions can be A is greater than 2 and B is greater than 8, A less than 2 and B less than 8. But here I am just considering only one condition in order to test the branch. That is about the branch coverage. Okay. Any doubts up to this point for anybody? You have a branch coverage. This particular technique I call it as a branch coverage. Okay. I also have something called condition coverage. Okay. What is the difference between branch coverage and condition coverage? Okay. Here in condition coverage, my objective is to test the individual conditions with possible combinations of Boolean input for the expression. Okay, that is what I call it as a condition coverage. That is the difference between branch and condition. Here you are testing the condition, not the branch, not the outcome of a particular expression. You are going to test individual conditions with various possible combinations of Boolean input for the expression. It is the modification of decision coverage. That is, branch coverage is also called as decision coverage. But compared to branch coverage, this will provide the better coverage or better testing support. Okay, and whatever limitations we came across under branch coverage can be resolved with the help of condition coverage. Okay, suppose if you look out for this particular thing, A and B, okay, with the previous example, okay, we are going to test with the help of all the possible Boolean values for A and B and the outcome associated with the values that have taken as input. Okay, same example they have taken over here. But branch coverage, I will just take up one value, possible value for this condition, whether a particular branch gets executed or not. That's it. That is the end of branch coverage. But here, I'm going to test for all the possible values for A and B, and the outcome I'm going to test. Based on the outcome, I'm going to arrive at the coverage. So that is about the condition coverage. Okay, whenever there are compound conditions involved, okay, if there are n number of conditions are grouped together as one single condition, in that case, the number of test cases will increase exponentially, which is actually not desirable one. Okay, so that is one limitation associated with conditional testing or condition testing. Okay, if n number of conditions I'm grouping together as one single condition, it is very hard for me to test using one test case. I have to design n number of test cases which may increase exponentially, and that is not desirable one. Okay, and what is the adequacy criterion which is associated with condition coverage is that each basic condition that I have written must be executed at least once. Okay, unlike the previous one, how do I measure the coverage with respect to conditions that I have written in the code is that the number of truth values taken by all the basic conditions divided by 2 into number of basic conditions which are present in the code. Okay, I'll just tell you the examples for each one of them, how the numericals can be given with respect to coverages in the next session. Okay, so until that, please go through these things: statement coverage, branch coverage, and condition coverage, and which all are the formula that we'll be using in order to measure the coverage associated with each one of them. Okay, unlike the previous two things, the formula is different with respect to condition coverage. What is that? Number of truth values taken by all the basic conditions. How many truth values it can have? Two only. Okay, we'll just look into the numericals with respect to these things. Divided by, why 2? Because it can be either true or false into number of basic conditions which are present within your code. So this is what I call it as a conditional coverage, and it is different from branch coverage. It is different from branch coverage. Okay. Any doubts so far for anybody? Okay. In the next session, we'll be discussing about MCDC, that is modified condition bar decision coverage. Okay. We'll be studying about modified condition and decision coverage in the next session.